Welcome to this video on persistent disks, Google Cloud Platform's block storage solution for virtual machines. Persistent disks are a fundamental component of GCP storage services, providing durable and reliable storage that can be attached to your compute engine instances. Throughout this video, we'll explore what persistent disks are, their different types, key features, and best practices for using them effectively in your cloud infrastructure. Persistent Disk is a network-attached block storage service designed specifically for Google Cloud Platform's compute engine virtual machines. Unlike physical hard drives that are directly connected to a computer, persistent disks connect to your VMs over the network, which gives them unique advantages. They are durable and reliable, with automatic encryption and built-in replication to protect your data. One of the most important characteristics is that they have an independent lifecycle from VM instances. This means that even if you delete a virtual machine, the persistent disk and all its data remain intact and can be attached to another VM. Let's dive into the key characteristics that make persistent disks so versatile. First, as network storage, they connect to VMs over the network rather than being physically attached, allowing for greater flexibility. Second, they offer flexible sizing, meaning you can resize the disk capacity without stopping your virtual machines, which is crucial for growing workloads. Third, persistent disks support multi-attach capability in read-only mode, allowing multiple VMs to access the same disk simultaneously. Finally, they provide snapshot functionality, which creates incremental backups for data protection and disaster recovery purposes. Google Cloud offers 4 distinct types of persistent disks to match different workload requirements. Standard persistent disk uses hard disk drives, or HDDs, making it the most cost-effective option for sequential I/O operations, ideal for backups, archives, and batch processing. Balanced persistent disk provides SSD performance at a lower cost than pure SSD, making it perfect for general workloads and boot disks. SSD persistent disk delivers high-performance solid-state storage for latency-sensitive applications like databases and high IOPS workloads. Finally, extreme persistent disk offers the highest IOPS and throughput with the ability to provision performance independently of disk size, best suited for high-end databases and analytics workloads. Zonal persistent disks replicate data within a single zone to provide high availability. This is the lower-cost option compared to regional disks, making it the default choice for most workloads. However, it's important to understand that if an entire zone experiences a failure, the availability of your disk will be affected. Zonal disks must be in the same zone as the VM to which they are attached. This makes them ideal for applications that don't require cross-zone redundancy, but still need reliable, persistent storage within a specific geographic location. Regional persistent disks take availability to the next level by replicating data across 2 zones within the same region. This provides automatic zone failure protection with failover capabilities, ensuring your data remains accessible even if one entire zone goes down. The trade-off is that regional disks cost twice as much as zonal disks. They use synchronous replication to ensure data consistency across both zones, making them the right choice for critical workloads that require high availability and cannot afford downtime due to zone-level failures. Persistent disks are built with enterprise-grade durability and reliability features. All data is automatically encrypted both at rest and in transit by default, ensuring your information is always protected. Built-in redundancy stores multiple replicas of your data across different physical hardware, protecting against hardware failures. Additionally, data integrity is maintained through checksums that verify data correctness on every read and write operation. These features work together seamlessly to provide a robust storage solution that you can trust with your most important data. Persistent disks come with several powerful features that enhance their flexibility and usability. Live resize allows you to increase disk size while the disk is attached to running virtual machines, eliminating the need for downtime. Snapshots create incremental backups that are stored in cloud storage, providing efficient data protection. Hot attach and detach capabilities let you move disks between VMs without any downtime. Finally, you can clone disks across zones by creating new disks from snapshots in any zone, making it easy to replicate your data across different geographic locations. Understanding performance characteristics is crucial for optimizing your persistent disk usage. Performance follows size-based scaling, meaning that IOPS and throughput increase as you create larger disks. However, performance is also capped by VM resource limits, specifically the vCPU count and machine type of your instance. This means that even with a high-performance disk, you won't achieve maximum performance if your VM doesn't have sufficient resources. Extreme persistent disks offer a unique advantage by allowing you to configure IOPS independently of disk capacity, giving you precise control over performance without over-provisioning storage. Persistent disks are versatile and support a wide range of use cases. They're commonly used as boot disks, providing primary storage for virtual machine operating systems. For databases like MySQL, PostgreSQL, and MongoDB, persistent disks offer the performance and reliability required for data persistence. They also work well as file storage, providing shared data volumes for applications that need to access common files. Finally, they excel in disaster recovery scenarios, where snapshot-based backup and restore solutions ensure business continuity and data protection. Let's wrap up by discussing some important limitations and best practices. On the limitations side, you cannot decrease disk size after creation, so plan your capacity carefully from the start. There's a maximum size limit of 257 terabytes per disk, though this varies by disk type. Regional disks are limited to replication across just 2 zones within a region. For best practices, always use snapshots for regular backups to protect your data. Monitor disk performance metrics to ensure you're getting the performance you need. And finally, choose your disk type based on your specific workload requirements to optimize both performance and cost. Following these guidelines will help you get the most out of persistent disks in your Google Cloud infrastructure.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.